Hello, I'm Song-Young-Chul from DTM Lab. In this video, I will present the title of Predicting the Number of Confirmed Cases of Infectious Disease using Opinion Mining. This paper proposed an algorithm to predict the number of COVID-19 confirmed cases by performing opinion mining based on social data and to see if the qualitative features shown in social data help predict the number of confirmed cases. The contents will be as follows. As human and property damage grew, the influence of infectious disease began to draw attention, and studies are being conducted to reduce the damage by predicting the number of confirmed cases. When information pertaining to the risk of the COVID-19 is spread through social networks, negative events can be transmitted through repeated exposure, resulting in acute stress. The stress of this infectious disease causes people to change their behaviors to cope with it. Changes in people's behaviors and the implementation of preventive measures in infected areas can affect the population density and quarantine, thereby curbing the spread of infectious disease. So it is considered meaningful to predict the number of confirmed infectious disease cases by analyzing people's opinions on infectious disease on social networks. Studies using AI for predicting confirmed cases mainly used data on the number of confirmed cases per day. And also, there were many studies using a quantitative approach of opinion mining in the past. However, it didn't reflect the qualitative implications of the opinion. There is a traditional method of predicting infectious disease named SIR. SIR model is an infectious disease prediction model that predicts the number of confirmed cases using linear relationships. And today, there are many AI methods to predict confirmed cases. ARIMA and TMSMM AR self-regression time series models are used to predict confirmed cases. And LSTM and GRU deep learning models are also used to predict confirmed cases. And also, several machine learning techniques have been used to predict the number of people vaccinated. The opinion mining is a big data analysis technique for analyzing and processing vast amounts of social text data. Opinion mining can be used to identify people's behavioral characteristics and expected phenomena through trend analysis and future prediction by using large numbers of opinions published on the internet. In this study, sentimental analysis, one of the opinion methods, is used, and the method is as follows. The study targets are identified and data with characteristics that the targets write or represent the target is collected and preprocessed. Degrees of positive, negative, and satisfaction are used to select the characteristics to be extracted from the data. And then positive, negative polarities are extracted, and to extract polarities, sentiment dictionaries and rule-based polarities are typically derived. This is the entire framework of this study. First, collect data related to infectious disease on social media. Second, proceed with opinion mining of data to check the sentiment polarities of people involved in the epidemic. Third, sentiment values are used in machine learning techniques to predict confirmed cases of infectious disease. In the data collection and pre-processing, this study collects tweet data of 30 months after the first confirmed case of COVID-19 using Python. And the number of COVID-19 confirmed patents used in the study is collected at the Seoul Open Data Plaza. After data collection, duplicate data were deleted from the collected social data, and news data and promotional posts that didn't contain user opinions were excluded. And then post tagging was performed using Kokoma for Korean language data. To define sentiment dictionary, this study collects a Korean language sentiment dictionary named Kosak and expands sentiment dictionary. Sentiment polarities are determined based on the cosine similarity of words corresponding to positive, negative words by using the word-to-back method. After defining sentiment dictionary, the sentiment polarities are calculated. The average polarity of each tweet was calculated by substituting the text data with adjectives, verbs, adverbs, nouns, and radix polarities in the sentiment dictionary. The polarities of the daily text data were collected, and the daily polarity was calculated dividing positive, negative polarities. This study uses DNN, LSTM, and GLU machine learning models to predict the next day's number of confirmed cases. As for the input, the number of confirmed cases in the previous n days and the daily positive and negative sentiment polarities are used. By comparing the result with the sentiment polarity and the result without the sentiment polarity, it is checked whether the sentiment polarity helps the prediction result. The model's layer is shown like this. Research. For data collection, this study searches terms of collected using a total of 5 words, including 4 corona-related words: corona, COVID-19 confirmed, and COVID-19 vaccine, based on Google Trends and epidemic. The collection period was February 24, 2020 to March 21, 2022, and a total of 1,080,000 data were collected. For the data pre-processing, this study removes duplicated, missing values, and advertising text. Post-tagging of this text data was performed using a Kokoma post-tagger. Defining sentiment dictionary process. To match the data collected in the Kosak Korean Sentiment Dictionary and the social data, a sentiment dictionary was produced using the word-to-back technique. The minimum number of appearances was 100, which accounted for 0.01% of the total sentence data, and the skip-all model was used as the running method. Words from the Cossack Sentiment Dictionary were inserted, and words with a cosine similarity of 0.8 or higher, derived through word-to-back, were added to the new Sentiment Dictionary. And then an example of sentimental dictionary is shown in the picture below. After defining sentiment dictionary, this study calculates sentiment polarities. Left table summarizes the polarity of each text data, and right table is a normalized table containing the average values obtained by dividing the daily polarities by positive and negative polarities. In the prediction results, lowest MAPE value at 10.088% in GRU model for the period of 14 days, which is the estimated incubation period for COVID-19 announced by the Korea Centers for Disease Control and Prevention. LSTM and GRU models have good prediction results when using the data that included polarities. The p-values of 0.0012 and 0.4 LSTM and GRU were obtained, and the results obtained using the data that included polarities were statistically significant, better than those obtained using the data that excluded polarities. The graph of the prediction results is shown in the following figures. Implication and discussion. According to MAP set as the error value and the characteristics of the remarkable graph, better predictive are generated by considering the qualitative characteristics of social data in the prediction process. This study's results indicated the need to consider the incubation period announced by the Centers for Disease Control and Prevention when using social data to predict infectious disease. It is possible to update the sentiment dictionary to reflect the newly emerging language trends and conduct sentiment analysis automatically so that feature ensures that the proposed model can be updated and applied at a certain point in time in the future. Thank you.